Hello, this is NB drumcrow. It is a Norns mod that turns crow into a synthesizer that you can play using the voice library NB. NB drumcrow can turn each output on crow into a synthesizer. You can play each output individually, round robin, or all simultaneously. Additionally, there's paired operation, where you can trigger 1, 2, 3, or all 4 of the outputs at once. Each output has an oscillator, 3 cycling envelopes used to modulate parameters of the oscillator, and then that outputs into a quantizer, used to quantize to a volt per octave signal, or you can use the quantizer to quantize audio signals for distortion. You can set each output to be a synthesizer, a control voltage trigger or gate, control voltage envelope or LFO, or you can convert the Midi note from your NB sequencer into a volt per octave voltage signal. You can install NB drumcrow using Maiden by entering the following command here, which is just install and then the URL to the GitHub repo. You can find NB drumcrow in your system mods list. And if you scroll down, you should see NB drumcrow right there. To enable the mod, turn encoder 3 to the right till you see a plus sign, and then that means that Norns will enable this mod next time it restarts. We can check to see if it enabled correctly by going to System, Mods, and then there should be a dot next to the mod. There's also 2 additional parameters in this mod menu. You can set the number of crows that you're using. You can either use 1 or 2 crows to expand the number of outputs from 4 to 8, so you could use NB drumcrow as an 8-voice synthesizer. You can do this by connecting 2 crows via I2C and then uploading the audio code to both crows. There's also another parameter for controlling whether or not the audio code is automatically uploaded to crow when you start a Norn script. You can set this to either on or off. From here, we can back out and start a script that uses NB, such as Pit Orchestra. And this should upload the code automatically to crow at the start of the script. We can check this by looking at crow here. We can check to see if this uploaded correctly by turning our NB voice to drumcrow 1. And then let's set that to behavior 4. And we can see that a light is flashing on output 1, which means that our script is triggering the first output of drumcrow. Let's adjust some of the parameters here for NB drumcrow. So wherever your NB voice is, you'll see the parameter list come up below. And then we have a lot of different parameters here for each output on Crow. Towards the top, we have some global parameters. Then we have some oscillator parameters like pulse width, transpose, and Bitcrush settings. And then we have each of the 3 cycling envelopes, amp, LFO, and note. So starting from the top, we have resend code to Crow. If you press key 3 here, this will resend the audio code and upload it to Crow. So we can show that here. There you go. And now the Crow has the audio code resent to it. If for some reason Crow crashes, or your modulator gets turned off, or something like that, then you can just use this to resend the code to Crow, and it will set all of the oscillator parameters and all of these parameters as well to whatever is listed here in the Nord's param menu. So if you were working on a patch and then something happens, then you can just resend the code to Crow and will update all of the outputs and oscillators to the current values. Next, we have the Param Behavior. So if you set a value here, let's say pulse width, we can hear that change. And you can see it change on the oscilloscope on the bottom left. But this only sets one of the outputs as intended. If we go to change this voice to drumcrow 2, you can see the second output is now lighting up. And that value did not change. So if you have, let's go back to number 1. If you have the Param Behavior set to all, then when you change a value here, it will set the pulse width value for all 4 of the outputs on Crow. So you can hear that by going to drumcrow 2, and that's has now had its pulse width changed as well. This is very useful when you're using all 4 outputs at once and you want to adjust the pulse width of all 4 of them, or adjust any parameter all at the same time. Go back to individual, then now we're only changing things for the first output of Crow. The trigger behavior changes how the outputs are played when it receives a note. So if it's individual, then every time drumcrow voice 1 is triggered, then it will just trigger this one output. If it is round robin, then you can see now that it is going between all 4 of the outputs and incrementing between them for every new note that is played. You also have all, where it triggers all 4 outputs at once. So you can see how, in combination with Param Behavior all and Trigger Behavior all, or say round robin, you can use this as a polyphonic synthesizer where you can play 3 notes in a row and it plays across 3 different outputs. Or if Trigger Behavior is all, then you can use this as one monosynth with 4 oscillators that you can use. Which gets me to the next parameter here, the global detune. This will detune the oscillator frequencies from a root value of the first oscillator. So the first oscillator will be the requested note, and then the other 3 will be detuned a bit more as you go from number 1. So you can hear that. So it's a slight detuning of all of the oscillators, and you can get this kind of sound. This goes pretty high. Go to like 0.3 here, we can get the chord. It goes all the way up to 1. So you can explore different values for different chords that might be in here. I'll set that back down to 0. I'll set both of these to individual, so we're just back with output 1. Next we have the synth preset. So for output 1 here, we have the initial preset, and that is the preset that is loaded when NB drumcrow starts. If you are editing things, say this pulse width down here, and we want to go back to the initial preset, we can always just hit load preset. And now it's back to being a sine wave with a short decay envelope. There's a few other presets on here that are used for different use cases. The presets are set up for different use cases. One is a kick drum, one is a snare drum, one is a hi-hat, short noise burst. This is a control voltage trigger, so it will just output a control voltage trigger or gate that you can adjust the gate length based off of the amp envelope decay, or I should say cycle frequency. The CV envelope is used for control voltage envelope, where you could use this for LFOs or envelopes. And this uses the internal envelopes modulating the amplitude. You can have multiple envelopes such as amp, LFO, and note all modulate the amplitude at once for a variety of wave shapes, as you can see. And then CV pitch, where this will convert the MIDI note that is playing from your NB sequencer and convert it to a volt per octave constant voltage signal, a volt per octave signal that you can use to play other oscillators melodically. If you have a patch that you want to erase, or you want to go back to an initial state, you can use the init preset, and then with Param Behavior all, you can load the initial preset, and it will load it for all 4 outputs of Crow. Similarly, you could select any preset here, such as the kick, and with Param Behavior as all, you could load this preset to all 4 outputs. Using the variable saw synth model, this will oscillate between 2 voltage points, going up and down between those 2 points. The path that we take between those 2 points is what the synth shape is. So you can see this by right now where you have a sine wave. We also have a linear path between those 2 up and down voltages that creates a triangle wave. Crow also has logarithmic, where it rises quickly and then settles slowly. Exponential, where it's the opposite. A now shape, where you get a square wave, where it immediately jumps to the voltage destination. Wait is the opposite of now, where it waits and then jumps to the voltage. Overestimates the target voltage and then settles back down. And under does the opposite, where it underestimates the target voltage and settles. And rebound implements a bouncing ball algorithm, where it goes to the target voltage and then bounces back a few times before settling. You can adjust this synth shape to get a variety of different tones and basic oscillator wave shapes. There are a variety of other synth models, but for this tutorial we're just covering the variable saw model. If you'd like to use any of these others, please refer to the documentation and understand that pulse width and pulse width 2 are used for different behaviors and functions for these other models. Birdsong is a parameter where you can increment through a selected scale and add the scale value as a transposition to the note that is playing. This is useful for drum machines where the requested note is often constant, and this can add a melodic variation to the trigger sequence. Or it can be used to add variation to an existing melodic sequence. Flock size controls how many outputs are triggered when a note is played for this NB voice. For example, a flock size of 1 will only trigger the drumcrow 1 output. But if we set this to 2, then you see that both 1 and 2 are now being triggered. Let's set this back to 1 and switch from drumcrow 1 to 3. If we turn up this flock size from 1 to 2, we'll now see the 3 and 4 are being triggered. This now loops around, so if you set to flock size 3, it will go 3, 4, and back to 1. Similarly, you can trigger all 4 of them by using flock size 4. If you have a flock size of 3, and we set trigger to be round robin, then you can see that when it's 3's turn to be triggered, it will trigger all 3 outputs at once. In combination with Birdsong, you can get a variety of different melodies, triggers, and pitches coming out of drumcrow. The Midi Note Amp parameter is used to map the MIDI note that is playing for your NB voice to the amplitude of your oscillator. This is mostly used to convert the MIDI note to a volt per octave signal in the combination with the CV pitch preset. However, you could set this on to just always have the output be droning. However, the amplitude will vary with the note as is intended. Maximum frequency is used to limit the maximum frequency of the oscillator. This can be useful in combination with some modulation for fake filter sweep style sounds, or for applying FM to the higher part of the frequency spectrum. Here I'm just turning it down to all of the outputs at once. You can hear how all of them now are frequency limited. We can modulate this value back and forth using an LFO. Let's put this a bit higher. Maybe a bit more modulation depth. Maybe turn up the frequency as well of this LFO. This preserves the desired note that your sequencer is playing while still being able to FM it. Transpose is used to offset the frequency of your oscillator from whatever note is being requested to play. For this patch, I've got the trigger behavior set to all, so all 4 outputs are triggering. And then I will transpose the first oscillator upwards. Maybe 7 half steps up, or a full octave to 12. Get back out, go to the second one. We can transpose this. Third output. Oh, we can create chords this way. The transpose goes pretty high, and then it also goes pretty low. Since Crow is DC coupled, these outputs can oscillate as LFOs as well at a really low value of transpose. While using the variable saw synth model, the pulse width can be used to change the shape and pulse width of the signal that is oscillating. If I set this all the way negative, you can see that the first half of the waveform goes towards the left, and the pulse width of the left side gets progressively smaller, and we get a sawtooth wave on the output. increase its time here. Similarly, if we go to the right, we can see that pulse width go to the right. Set this to now, we can see that the pulse width a bit more clearly. All the way at -1, we'll have a constant negative voltage, and all the way at +1, we'll have a positive voltage when using the Synth Shape now. We can do some pulse width modulation. If we go down to the LFO and modulate pulse width, it's currently at -1, so if we set this to 2, it should modulate all the way back and forth. As you can see here on the oscilloscope. If we turn this off, this applies to the variable saw synth model. However, the pulse width and pulse width 2 change in behavior for different synth models. For example, if we switch to the byte beat oscillator, this uses pulse width 2. And then if we adjust the pulse width parameter, you can hear that there's a pretty dramatic change in behavior going on. For more details about what pulse width and pulse width 2 are used for each of the synthesizer models, please look into the documentation. The 4 parameters with 2 caret symbols are associated with the Bitcrusher. The Bitcrusher uses the output quantizer on crow to do distortion and wave shaping. The Bitcrush parameter controls the number of volts that define the octave. Turn this up to 1, then that means that the output signal is now being quantized to a 1 volt per octave scale. If Corvus is off, then that means we are quantizing to the chromatic scale. If Bitcrush is 0 or any negative value, then that means that there is no quantization happening on the output signal. If we increase this to a larger value, say 5, then this expands the voltage range in which defines an octave. So we are now quantizing to the chromatic scale, but across a larger voltage range. If we increase this further, we'll get some stair-step patterns on the output signal that you can see on the oscilloscope. We can quantize to other scales as well: major, minor, pentatonic, and then some other customized ones. The Mutate parameter then modulates the values of the scale that we are quantizing to. We can also modulate a lot of these parameters. So if we mutate between 1 and -1, we can get an effect that is sonically similar to wavetable synthesis. Crow can only output +10 to 5 volts, and any voltages we request outside of that range will be clipped. You can use this to overdrive an oscillator if we have no Bitcrush. By turning up the amplitude to 2, we are now requesting a signal between positive 10 and negative 10. And you can see that the bottom half of the waveform is clipped at negative 5 volts. We can increase this further, but this last parameter limits the amplitude before the Bitcrusher to positive and negative 10. We can increase this limit to, say, 40, and now we have clipping on both sides of the waveform. Or we're going to decrease this to 1 volt, so now that the amplitude is limited between positive and negative 1. When used with the Bitcrusher mount, we can get a quick change in distortion values by changing this amplitude limit. For a more detailed look at wave shaping and distortion using NB drumcrow, check out the other video which I've made, which explores this idea in a lot more depth. Splash adds randomness to the oscillator frequency. At low values, you can kind of get this chorusy detuned effect, and at higher values, it starts to break down entirely. The 3 cycling envelopes are used to modulate the oscillator parameters. They are each 2-stage envelopes with a rise and a fall stage. The 3 envelopes are identical, except that they each have different initial values when loading the init preset. The 3 envelopes are amp, LFO, and note. The amp envelope has an initial value of 1 when modulating the amplitude. So this is usually used to modulate the volume of the oscillator over time. The LFO is set to loop, which means that it will continuously reset once the fall stage has completed, thus acting as an LFO. And lastly, the note envelope has a fast cycle frequency, which is useful for quick modulation of the oscillator frequency. Modulation depth for any parameter can be positive or negative. Modulation is additive. You set the base value of the oscillator parameter above, and then move away from that position positively or negatively depending on the polarity of the modulation depth. Modulation from all 3 sources sum together, so you can get some interesting behaviors by combining multiple envelopes. For example, if we use the note and the LFO to both modulate the frequency, maybe we turn this frequency up a bit. Or the example is to use pulse width, or if we set this to a negative value, and then modulate positively, value of 2, this will modulate the full width of the pulse width value from -1 to +1. Let's load our initial preset. Now we're back to clean slate. The cycle frequency controls the frequency in which this envelope oscillates, which is evident with the LFO here. Around 100 is the maximum value, and then it starts aliasing afterwards. It can also go very slowly, down to a value of 0.1. When used as an envelope, though, this controls the overall time of the rise and fall stages. So for amplitude, we can see that if you want to, usually it would be increasing the decay length from an ADSR envelope. But here we can just increase the time for both stages. Or decrease it. Next is the symmetry. Shown here, the symmetry controls the ratio between the rising and falling stages. The initial preset will set this to -1 for the amp. But you can see on the LFO, the symmetry is 0, where you get a half and half, 50-50 ratio between the rise and the fall stages. If we wanted an attack component here, we could similarly set this to 0. And now you can hear the volume fade in and fade out with the rise and fall stages. Or if we wanted all fade in, and then a really sharp decay, set this to all the way to 0.99. And then at 1, it will rise and then hold until it gets re-triggered. If you don't want to re-trigger the envelope, you can set the reset to off. Now that it's set to off, the envelope will go to completion to the end of the fall stage and stay there. So if we set symmetry to 1 with the reset off, you can get the oscillator to just drone. And then you can adjust parameters from here. So if you'd like 4 droning oscillators, you can set that up by putting the symmetry to 1 and turn reset off, while having a positive modulation value to amplitude. If you set the amplitude to 0, then there's no modulation going to the amplitude, so the amplitude stays at 0. At 1, this will produce an amplitude of positive and -5 volts. At 2, it will be +10 to -10. The Crow hardware can only output -5 volts, so you will clip the bottom half of the waveform at -5 volts. Set this back down to 1. Let's go symmetry to -1 for a short decay envelope. And let's set the amp envelope to re-trigger when a note plays. There it is. Next is the curve parameter. This controls the shape of the modulation in both the rise and fall stages. At -5, we will have a logarithmic shape that rises quickly and settles slowly. Towards 0, you'll get a linear shape. And then towards 5, you will get an exponential shape. This is useful for getting a pluckier sound while modulating the amplitude, or for varying the wave shape while using it as an LFO. Let's load our initial preset. And lastly, we have the loop parameter. Loop can be set on or off, and it determines whether or not the envelope will trigger again once the falling stage is completed. If it's on, the envelope will continue to loop, just like how the LFO does. If it's off, then the envelope will complete once it reaches the end of the falling stage. So you can set this on for the amp envelope as well, since all three amp, LFO, and note are identical. And maybe if we shorten the frequency here, or the time I should say. Now we are just looping the amplitude on and off. Lastly, reset controls whether or not the envelope will re-trigger when a note is played. If it is on, then the envelope will start again from the rising stage. If it is off, then nothing will trigger the envelope and will stay at the end of the falling stage. If you have two crows that are connected via I2C, then NB drumcrow can be expanded to use all 8 outputs across both crows here, instead of just the 4 outputs of one crow. First, you would go to the System Mods menu and find NB drumcrow, and there's a list here where you can set the number of crows to 2 using Coder 3 to change that value. I have the auto upload set to off for this demonstration. Then we would need to restart our Norns to apply these changes. This will create 8 NB voices on Norns to select from in your NB selector. And we could show that here by going to a script that supports NB, such as Pit Orchestra. Here we are. Going to the parameter list. And if we scroll through here, we can see drumcrow 1 through 8 now appears on our NB selector list. So let's just pick drumcrow 1 for now. And I need a behavior 4 to see that the snake starts eating food. Good. Now, if you have not yet connected your crow, do so with the USB. So I'm going to connect it first to this crow on the right. And then we need to resend the code to crow by pressing this option here. Press key 3. And there it is. So now this is drumcrow voice 1. If we select different voices, we can see different outputs lighting up. If we go into 5, though, we don't see or hear anything yet because we have not yet sent the code to the second crow. So let's go back to 1 here. Disconnect crow and connect it to the other one, the second crow. There we go. Alright, and now we go back to any drumcrow voice here, and we resend the code now to this crow. Now we should see it lighting up. However, you might notice that drumcrow 1 is lighting up on the crow that is now connected via USB. Whichever crow is connected via USB, those 4 outputs are regarded as drumcrow 1, 2, 3, and 4. So if I go and select between 1, 2, 3, and 4 now, you'll see the second crow is lighting up. However, if we go to 5, the first crow that we uploaded to has 5, 6, 7, and 8 that we can now trigger. If we go back to drumcrow 1 and then set the trigger behavior to round robin, we should see this snake now playing notes across all 8 of the outputs of crow. The Param Behavior still works as well, so we can set the pulse width of all of the outputs at once. We have a difference in volume just because of my mixing situation here, but they should be identical. Detune also works to detune all of the voices a little bit from each other. It's a bit more extreme because the detune becomes more... each progressive oscillator becomes more detuned than the next from the... in ratio to the first drumcrow voice oscillator. So maybe if we set trigger behavior to all, there we go, bit loud. And now if we detune, and you have 8 oscillators detuned from each other. Flock size also works. If we set this to 2, then it should be triggering in 2 oscillators each. And this sets the flock size for all of the oscillators at once because we have Param Behavior all set. Set this to say 4, we should get 4 oscillators triggered at once. We can set Param Behavior back to individual, and then start setting different values per output. Say output 2 will be a now shape, transposed up to an octave. Let's select drumcrow 3. Maybe that'll be a flock size 8. So whenever the third output is triggered, it will trigger all 8 voices. Just an example. Please note that the 8-voice mode is not supported when using a teletype to sequence NB drumcrow. Teletype can only sequence the 4-voice version with a single crow, and does not support the 8-voice version. Thanks for watching. I hope you enjoy NB drumcrow.